Welcome to Engineering Simplified. What actually happens if you connect an electrolytic capacitor backwards? It's not just it won't work, get the polarity wrong, and that capacitor can genuinely fail violently. Here's why. Electrolytic capacitors aren't like your typical capacitor. Inside, a paper-thin oxide layer acts as the dielectric, formed onto one electrode during manufacturing, specifically so current flows one direction through it. That's what gives them so much capacitance in such a small package. But that oxide layer only stays insulating when the voltage across it matches the polarity it was formed with. Reverse it, and the layer starts to break down almost immediately. If you're enjoying this, like, comment, and subscribe, and check out our Electrical Engineering Explained playlist for more. Back to the maths. Once that barrier fails, current starts flowing where it shouldn't, and the capacitor begins heating up internally. The liquid electrolyte inside starts to boil and decompose, releasing gas inside a sealed can, and pressure builds fast. Most electrolytic capacitors have a scored vent on top, specifically designed to rupture in a controlled way and release that pressure. Without it, or if the buildup happens too quickly, the capacitor can fail explosively, sending hot electrolyte and casing outward. The common mistake is assuming every capacitor works either way round. Ceramic, film, and mica capacitors genuinely don't care about polarity. But electrolytic and tantalum types absolutely do, which is exactly why they're clearly marked with a stripe or a plus sign. So remember, polarity on a capacitor isn't a suggestion. Get it backwards, and you're not just breaking the component, you might be launching it. Drop a like, comment the topic you'd like to see explained next, and subscribe. It genuinely helps this channel grow. See you in the next Engineering Simplified video.